So today we're going to do partition coefficient, and for partition coefficient your first step is you're going to put some substance, which is benzoic acid, in a test tube. You're going to weigh about 100 milligram of benzoic acid. So how do you weigh? First of all, use an analytical balance like this one. I want you to notice that it's completely clean and everything is perfect. It's reading 0. We never know when was the last time they calibrated this machine. So ideally, if I don't know when it was calibrated, I would never tear the balance. I always weigh by subtracting. And the reason we do weigh by subtracting is so that if there is any calibration error, it will be subtracted when you subtract your numbers. So first step, we want to weigh 100 milligrams in a test tube. So I can't weigh it directly in the test tube without holding the test tube on the balance. So what I'll do is weigh the beaker with the test tube. So here we have, and make sure you have a little notepad to write your mass. Another thing that I observe that students sometimes make these mistakes is that this is a very expensive balance and it goes to 4 decimal places. That shows the precision of the balance. So never drop any digit when you read from an analytical balance, because these are pretty much an indication of how precise your measurement is. So I'm going to write it down here. Mass of tube plus beaker is 44.4577 grams. I know exactly that mass. Now I want to add 100 milligrams. So how do you do it? You don't take it out and put it back in, or you put too much and remove. We never do that. So we always work this way. You take a tiny bit on the tip of your scapula, and then you go inside, and I'm going to keep tapping. So I know I want 100 milligrams, so I went from 44.4, I want to take it to 44.5. So all you do is kind of tap on the scapula to allow the powder to go down very slowly, one little piece at a time. So it says 44.47. I'm still far from 44.57. So again, a tiny bit on the tip of the scapula, and without touching the beaker or the test tube, you just tap slowly, allow the powder to go in. So I'm still at 44.48. I want to go to 44.55. So again, I'm just tapping very slowly. So here's my final reading. It's the mass of tube plus beaker plus acid is 44.5611. So I went slightly over 100 milligrams, but that's okay. It's very close. So here's our 100 milligrams of benzoic acid, and what I'm going to do is add 2 milliliters of methylene chloride and 2 milliliters of water. Now for methylene chloride, make sure you use the glass pipette, because methylene chloride can dissolve the plastic because they both have similar polarity. So you can use a graduated cylinder and measure roughly 2 milliliters. So I'm putting here 2 milliliters on my graduated cylinder. And that's about 2 milliliters. And then I can do the same with water. And water is roughly 1 pipette full. I can add it to the graduated cylinder just to be sure. So now I have my 2 solvents, the water and methylene chloride, and you can put them in your test tube. So you already see 2 layers. The top layer is the water, the bottom layer is the methylene chloride. Then you put it. Then you put a stopper and you shake until all your crystals dissolve. And it looks like they're already dissolved, so all you have to do is just let it sit for the layers to separate. See, we want to remove all the bubbles. So as you can see, the benzoic acid is gone. We want to know how much of it is in the water, how much of it is in the methylene chloride. Instead of collecting both layers, the water and the methylene chloride, we can just take out the water layer and then dry out the methylene chloride layer and then evaporate the methylene chloride. So that's the reason we have here a water bath that is being heated. When you prepare a water bath, you have a beaker, put some water in it. Tap water is okay because all we need is just to heat the water. And don't forget to put boiling chips. So we have 2 boiling chips in there. Now I'm going to remove the water layer here so we can use a glass pipette. So here, our glass pipette, Pasteur pipette, you have a pipette bulb, you put it on top, and then you put it in your test tube and try to remove just the water layer slowly. You have another tube ready to collect your water layer. Now to have good results, you want to remove all the water without taking away your methylene chloride layer. But there's still some residual water in there. And when we do extraction, when you read in the handout, the last step is to remove that residual water. So you need a drying agent. And in this case, it's sodium sulfate. So you take the tip of your scoopula. You don't really have to measure the sodium sulfate, but don't put too much because the more of it you put, your crystals will adhere to these crystals and you might lose some of it. So the idea is to have, but this is not a good approach. You should first transfer this in a dry test tube so that at least you don't have all the water that's on the side. So 2 things, you can either pipette it out with a new glass pipette. So pipette it out in a clean, dry test tube. And the reason I'm doing this is to make sure that the water on the sides of this test tube doesn't stay on my substance. Now I'm going to put a little bit of the drying agent, which in this case is sodium sulfate. And you shake it a little bit. And something that shows if you have water in there is when the crystals clump to it and attach to each other. They stick to each other. That means you have a lot of water there, because all salts are hygroscopic, which means like they love to absorb water. And in this case, when they absorb it, they kind of attach to each other. So I'm going to add a tiny bit more. And then shake it. And you can let it sit for a few minutes to do its work. And then we'll transfer it into a dry test tube, clean and dry test tube. So at this point, I assume, as you can see, the liquid is quite clear. We can either decant it here, or you can pipette it out. So I prefer to decant it, but if you're not very comfortable with that, just use a clean glass pipette and pipette it out slowly. So now, here's my test tube with the organic layer, which is methylene chloride, and we want to see how much benzoic acid is in there. So all I have to do is evaporate all the solvent and then weigh it. So I'm going to put it here in that beaker, and while it's doing its work, we're going to start with the active extraction. So this was the passive, meaning that there is no chemical reaction involved. It's just dissolving the benzoic acid between the two layers. But in the second type of extraction, we want to make the benzoic acid react with a base, and then we're going to move it to the water layer and see how the extraction works. So here's the active extraction. So it's chemically active. We have here benzoic acid. So first step, we're going to add 2 milliliters of the methylene chloride, like we did earlier. Just measure 2 milliliters. So I'm roughly there. Okay, so this is 2 milliliters. And then I'm adding 2 milliliters of the 3 molar sodium hydroxide. So here we have 3 molar sodium hydroxide. I'm going to hold the cap here and just fill up 2 pipettes full of sodium hydroxide. This is 1, and this is 2. Now the next step is you put a stopper, and you can see already there's no more benzoic acid. It's all gone. I can still shake it a little bit and let it sit. So this is basically what we call an active, chemically active extraction. What happened to the benzoic acid is it definitely reacted with the sodium hydroxide. Since it's an acid and you put sodium hydroxide, it's a base, so you're going to have an acid-base reaction right here. Here. And again, methylene chloride is at the bottom. And you see here sometimes when you have these chemically active reactions and the solution is concentrated, it has the tendency to kind of be a little more cloudy. So what I want to do is, just like I did earlier, is remove the aqueous layer, put it in a test tube, and leave the organic layer to dry it to see how much benzoic acid is left over there. So how do we do this? So after we let it sit, you can see that the two layers are definitely separated. And just like you did earlier, you remove the aqueous layer and you put it in a clean test tube. And then the organic layer, we need to put it in another test tube that we're going to add the drying agent in it. So we are going to pipette or pour this organic layer into a test tube with some sodium sulfate. So I'm just going to transfer it, making sure that the water here stays, and then a little sodium sulfate, and then stir it like we did earlier, and let it sit for a few minutes to remove all that water that is in the methylene chloride, in case you have any. So after you shake it, you let it sit like we said. And then in the meantime, let's look at this aqueous layer. Normally, since it's an active extraction, most of the benzoic acid should be in this layer. But at this point, it reacted with the base, so it's not anymore benzoic acid, it's a benzoate. So here we have sodium benzoate and water. But to recuperate it again, to see that we have benzoic acid there, is if we add some hydrochloric acid, the benzoic acid will be a solid. So I'm adding here a few drops at a time, some hydrochloric acid. Of course, it's an exothermic reaction, but you see already that there is a white precipitate, and that's the benzoic acid that is being neutralized. The benzoate is turning back into benzoic acid. I can add a little bit more just to show you that we now have the benzoic acid in this test tube. And and 100 milligram is not a lot, and you start already to see that there is quite a few crystals. I also see that I have a little bit of the methylene chloride. That would be a good thing to write down when you write your discussion. If you took a little bit of your organic layer here, you're probably going to lose a little bit of mass of the benzoic acid in here. Now, what's my last step is to transfer my organic layer in a clean pre-weighed test tube. So what I did earlier is I did weigh this test tube to know later how much benzoic acid is in there. And I just need to let it dry, evaporate, and this is the previous test tube. It's done. So we can now measure here how much benzoic acid is in the passive extraction, and then while we wait for the active extraction to produce the benzoic acid. So my last step is to go and weigh it, so I'm ready for my calculation. So I did weigh earlier the test tube with the empty test tube, and now I have my test tube and beaker plus the final product, and it's 44.6172. It looks I'm getting very close to pretty much what I started with earlier. Now, if it looks too high, I'm going to subtract here. If it's a little higher than what you put, what does it indicate? It indicates that you probably still have some water. So make sure when you're weighing your test tube, there's absolutely no water left whatsoever in it. So maybe one thing you could do is put it again, let it dry a little bit more, and weigh it again to make sure that the mass doesn't change. So to conclude, let's look at these two test tubes which show how much benzoic acid is in the organic layer. In the passive extraction, you see that we have a good amount of benzoic acid, which shows that benzoic acid dissolves in methylene chloride. That's the reason we have some of it here. And of course, if we evaporated the water, we could also know how much benzoic acid was in the water. But by just subtracting what you put in at the beginning and what you have left here, you pretty much have an idea of how much benzoic acid is in the water layer. So you can see by just visually, without even the masses, this definitely gave us more benzoic acid. This is the active extraction, meaning that we put the benzoic acid and we made it react with the sodium hydroxide. So what happened is the benzoic acid ended up in the aqueous layer, and that's the reason here in the organic layer we have very little left. So most of the benzoic acid was in the aqueous layer, and that's what you see here. That's the precipitate that we formed. So in the active layer works a lot better because it works chemically. So all the benzoic acid will be forced to leave the methylene chloride layer and go to the water. And that's pretty much this kind of lab. The key thing is later to do your calculations. And not only do we have an example in the handout, but I also refer to a few videos for you to check. And thank you.